Hello students, once again welcome to our channel Physi Dive, and this is your teacher Alexi Rajan. Today we are going to study a very important topic of 10th standard NCERT, that is image formation by convex mirror. So two cases are there, very important cases. So just dive in without wasting time. So to the class. So image formation by a convex mirror. We have seen the image formation by concave mirror, and there were 6 cases we have studied one by one. And those who haven't gone through the previous video, I will just pin it somewhere here so you can just go through and come back. Okay, here the next case is convex mirror. Let this be a convex mirror. Let this be a convex mirror, and you can see in the case of a convex mirror, the principal focus is at the right side of the mirror. Why? Because virtually it means. So virtually we are getting the images there, and we have seen what is principal focus and all in the previous session. We have, if those who haven't gone through, kindly go through those videos also and come back. Now in the case of convex mirror, there are two cases. So what are those cases? One case is that when object is placed at infinity, and the second case is that when object is placed anywhere between infinity and pole. We'll see one by one what are the various image formation, what are the various properties of the image formed there, and all one by one. So the first case, that is when object is placed at infinity. We have a concept that when object is placed at infinity, then the light rays will be parallel to each other. It is not necessary, once again I am saying, it is not necessary that these light rays 1 and 2 be parallel to this particular principal axis. That is not at all necessary. But among them, that is light ray 1 and 2, they will be parallel to each other. I am just taking that they are parallel. In this scenario, I am just taking they are parallel to the principal axis also. Now what happens? You can say that, you can see that this is which type of mirror? Which mirror? This is convex mirror. So obviously this convex mirror is otherwise known as what? Diverging mirror. They diverge out each other. They will not meet in real. Why? Because in order to meet in real, then they should converge, and we can see that convergence only in which mirror? In concave mirror. But here it is convex mirror, so they diverge out each other, so they will not meet each other. So what happens? What you will do? It's the same procedure, that is you will extrapolate it backward, and you can see that they got extrapolated and they meet at a point here, and this is nothing but principal focus. You can see that it seems that the two light rays reflected are originating from this point, and we call it as principal focus. And we know the condition: when two light rays, the reflected rays, meet together at that particular point, what will be formed? The image will be formed. Here virtually they are meeting at which point? Principal focus. If these light rays 1 and 2, if these light rays 1 and 2 are coming in, are coming in such a fashion that they are not parallel to the principal axis, they were formed somewhere. The image will be formed somewhere at this particular focal plane. We call it as a focal plane. A plane consists of, the focus is known as what? Focal plane. So keep all those things in your mind. Now you got the point. Now where the image will be formed? The image will be formed at the focus or principal focus. In this case, principal focus. So we are going to write the properties there. Image is formed at focus, or here it is principal focus, or simply you can write focus, right? Okay, now what are the different properties of the mirror formed there? Are they meeting in real? No, they are not meeting in real. So you are getting a virtual image, and you know all the virtual images are what? Erect image. Because in the previous case we have seen most of the cases, 90% of the cases are real image formation, and there you got inverted. But here we can see that the image form is virtual, and then they are obviously erect. And the next thing is that about the size. What about the size? You can see here the object is kept at infinity, so obviously the size is bigger, and here you got the image as point size, as they are formed at the principal focus So it is point size, that means highly diminished. So these are the properties, various properties that you will get when an object is placed at infinity, in which case, in the case of a convex mirror. Straight to the next case, that is when object is placed anywhere between the pole and the infinity. So here is a case. You have a convex mirror in your hand, and these are the various terminologies. First one is pole, second one is principal focus, third one is center of curvature. I think that in the previous session, instead of the C, I had written R. Just kindly note that you just change that R to C, because R is radius of curvature, but that particular point is center of curvature, so you should write at C. Okay, a ray from this particular point, let this point be A, and let this point be B. Okay, now what happens there? Obviously, it is this ray one is parallel to the principal axis, so definitely it will just divert like this. And the next, I am just taking another ray from the same point, let it move and fall at the pole. So let this be I, so this will be R, means like this it will go. It means two rays, that is this in this ray and this ray, that is two reflected rays, they are diverting extremely. They will not meet anywhere in real condition. So what you will do, you will just extrapolate. Extrapolate means you will extend it backward, and you can see that this ray which is parallel to the principal axis, they will divert, and if you extrapolate, then definitely that extrapolation or extension will move through the focus, and this case, that is this particular ray, if you extrapolate, you can see that it will just move, and at this point they will meet. That means at this point you will get, as the two rays are coming from point A, this point will be A dash, and this will be the head, and here you will get the image. That means the image is formed somewhere between the principal focus and the pole. So you are getting, if you are keeping the object anywhere between infinity and pole, then definitely you will get somewhere between the principal focus. You will get the image somewhere between principal focus and the pole. If you get anywhere, the condition will be like this. Between these 2 points, you will get the image. So the various properties are, the image is formed between P and F. Next, are they meeting in real? No, they are not meeting in real. They are meeting virtually. So you are getting a virtual image. You are getting a virtual image. All the virtual images are erect image. You can see clearly here. And the next thing is that about the size. Your size, if you compare the object and image, you can see right here, that is the object is larger than the image. So the image is what? Smaller in size, or we can say it is diminished. So that's all for today's class. I hope that you got the point, and we'll see in the next class with a very new topic for class 10, that is sign convention, which is very important. You need to study those things, and then mirror equation, which is also very important for numerical problems you will get from that particular portions. So that's it. We need your support by your like, share, comment, as well as your subscription. So that's it. So we'll meet in the next class. Goodbye.